Okay, so have you ever actually wondered why some habits just instantly stick? Why some subjects make you want to pull your hair out while others feel like a total breeze? Or really how we actually bounce back from trauma? Today, we're taking a seriously deep dive into the literal physiological foundation of what makes you, well, you. Welcome to this explainer. We're going to break down the absolutely wild science of neuroplasticity and look at how we, quite literally, hold the power to shape our own minds.
Right, so let's just dive right into this. Why on earth do some of us learn things so much more easily than others? It's honestly one of the most fundamental mysteries of being human, isn't it? You see it everywhere, in classrooms, out on the sports field, or, when somebody's trying to pick up a new language. One person gets it in a week, and another just struggles for months. For the longest time, we kind of just assumed it was a fixed genetic lottery. You either had the knack for it, or you simply didn't. But modern neuroscience, it actually asks us to look much, much deeper into the very physiology of how we learn.
And to really get to the bottom of that question, we've got to shatter a pretty massive misconception. For literally decades, the old myth was that after childhood or, right around puberty, your brain essentially just locked into place. Done. Finished. The only changes we thought happened in adulthood were the bad ones, like losing brain cells to aging or injury. But thanks to huge leaps in technology, specifically MRI scans, scientists have completely thrown out that old textbook. The reality? Our adult brains are highly, incredibly active. They don't just sit there silently when we're resting. They are constantly reorganizing. Literally every single behavior you engage in is actively rewiring your brain, no matter how old you are. Which brings us to the absolute core hero of this whole explainer, neuroplasticity. Basically, this is the brain's amazing ability to physically change and reorganize itself every single time you learn a new fact or practice a new skill. And I really want to emphasize this. It is not just some nice metaphor for personal growth. It is a literal, physiological process happening inside your skull right this very second. This crazy adaptability is the exact key to how we form memories, how we master skills, and, when you zoom out, how we actually construct our very identities over our lifetimes.
So how exactly does this whole process actually work? Well, the brain basically changes in three distinct ways to support learning. First up, chemical changes. Your brain runs on chemical signals bouncing between brain cells, or neurons. To help you learn something right now, your brain can rapidly boost the concentration of those chemicals. Boom, rapid change. Next, we've got structural changes. This is where the physical connections between those neurons actually alter and grow. It takes a bit more time. And finally, functional changes. As you use a specific brain region over and over, it becomes more excitable. The brain essentially shifts entire networks of activity around just to make that specific region easier to use next time.
Now, what's really fascinating here is how these mechanisms actually interact. Just think about trying to learn the piano, or, say, juggling. You practice for an hour, and by the end, you're hitting the notes, feeling great, you think, wow, I totally got this. But then tomorrow rolls around, you try it again, and you're completely back to square one. Why does that happen? Because that quick burst of improvement was just a chemical change. It's a short-term boost, kind of like cramming for a test. To achieve actual, lasting mastery, your brain needs those structural changes. Those physical, architectural upgrades in your brain, they take real-time and serious repeated practice. Short-term performance simply does not equal long-term learning.
And this brilliantly illustrates just how literal these structural changes actually are. Your brain honestly acts almost like a muscle that bulks up depending on exactly how you use it. For instance, people who read Braille literally develop physically larger sensory areas in their brain connected to their hands. Or, hey, if you're right-handed, the motor region on the left side of your brain, which controls your right side, is physically larger. And there's this really famous example with London taxi drivers. They have to memorize thousands of chaotic, winding streets without using a GPS, right? Well, they actually grow significantly larger brain regions completely devoted to spatial mapping. So if you're ever lost in London, you can literally trust their giant memory centers to get you home. It's wild. Your everyday behaviors are actively sculpting the geography of your mind.
But, seeing all this absolutely incredible adaptability brings up a pretty massive, sobering question. If our brains are so endlessly, awesomely neuroplastic, why do we ever fail? Why can't we just instantly learn anything we want? Why do kids sometimes struggle so hard in school? Or why do we forget things as we get older? And maybe most crucially, why don't people fully recover from severe brain damage? I mean, if the brain can constantly rewire itself, what's the actual limit to this superpower?
To really answer that, we have to look at the extreme edges of brain research, specifically stroke recovery. Now, recently stroke dropped to the fourth leading cause of death in the US. And on the surface, wow, that sounds like a massive victory, right? But it's actually kind of misleading. The actual number of people having strokes hasn't dropped at all. We haven't actually solved the core problem. We've just gotten a lot better at keeping people alive right after a severe stroke happens.
And because we're successfully keeping people alive, but still really failing to help their brains truly completely heal, stroke has unfortunately become the leading cause of long-term disability in adults worldwide. People are having strokes at younger ages, and they're living much, much longer with these severe disabilities. And researchers are the first to admit that, frankly, the medical community just hasn't cracked the code on effective rehabilitation interventions yet. It creates this enormous, heartbreaking societal puzzle. Like, how do we actually unlock that incredible neuroplasticity when the brain has been catastrophically damaged?
This huge medical hurdle actually reveals a fundamental truth about neuroplasticity. There is absolutely no magic drug. You can't just swallow a pill and automatically rewire your brain. The single absolute best driver of neuroplastic change is your behavior. But here's the massive, massive catch. To relearn a motor skill after a stroke, or honestly even to master a highly complex new skill in everyday life, the required dose of behavioral practice is just staggering. And delivering those huge repetitive doses of practice is physically exhausting for the patient and incredibly, astronomically expensive to provide in a standard healthcare setting.
And totally complicating this need for massive practice is a super frustrating reality. Patterns of neuroplasticity are highly, highly variable from person to person. Now, for the longest time, this variability drove scientists completely up the wall. Usually, medical studies are designed to minimize all that noise, right? Researchers want a nice, clean, predictable average. But when studying brain recovery, researchers finally realized that this messy, chaotic variability is actually the most informative data they could possibly ask for, because it definitively proves that no two human brains respond to therapy or to learning in the exact same way.
Plus, we really have to respect the fact that neuroplasticity is a total double-edged sword. We almost always think of it as positive plasticity, right? Learning a new instrument, mastering a tough subject, bouncing back from an injury. But there is also negative plasticity. See, your brain is aggressively efficient. If you stop using a skill, your brain will literally wire itself to forget it. Drug addiction, that is actually a form of negative structural neuroplasticity. Even chronic pain is basically the brain becoming dangerously hyper-efficient at feeling pain. Your brain is continually being shaped by literally everything you do, but equally so by everything you don't do.
And you know, this wonderfully unique, highly variable nature of our brains completely destroys some really popular cultural ideas. I'm sure you've heard that famous rule, right? That it takes exactly 10,000 hours of practice to master any new skill? Well, brain science tells us it is simply not that clean cut. Because our plastic brains are so uniquely shaped by our individual lives, that 10,000-hour rule is just a myth. For some uniquely wired brains, mastery might take way more practice. For others, it might take significantly less. There is absolutely no one-size-fits-all approach to learning, period.
So because there is no magic one-size-fits-all, stroke researchers are actually borrowing a brilliant concept straight out of cancer treatment: personalized medicine. They're actively looking for what we call biomarkers. These are specific, measurable characteristics of your individual brain structure and function. By identifying a specific combination of these unique biomarkers, doctors can theoretically match highly customized, tailored therapies to individual patients. It's like they're learning to read the unique landscape of a simple person's brain to perfectly predict how it'll change and recover.
But honestly, this goes so much further than just stroke recovery. Think about it. If the completely unique structure of our brains requires personalized medicine to heal, then it absolutely demands personalized learning to actually thrive in everyday life. We have to take this concept out of the clinic and bring it straight into our schools, our living rooms, and our offices. It perfectly explains why one kid absolutely thrives in a traditional sit-at-your-desk classroom, while another just feels totally lost. Or why one of your coworkers learns new software instantly by watching a video, while you might need to actually read the manual step by step. Every single one of us requires a customized learning environment.
And hey, remember, this variability isn't just about the differences between you and the person sitting right next to you. It exists entirely within yourself too. Like, you might have a brain that's perfectly wired to pick up a musical instrument intuitively, almost effortlessly. But that exact same brain might find learning to, snowboard completely agonizing. If that happens, you're not suddenly bad at learning. You are just navigating a totally different neural landscape. We really have to start studying how and what we learn best as individuals, and then totally adapt our approach to whatever specific task is in front of us.
So the crucial point here is, if you want to really harness your own neuroplasticity, you got to remember 3 main keys. Number 1, behavior is the ultimate driver of brain change. You got to take action. Number 2, and honestly this is perhaps the most surprising and encouraging fact of all, increased difficulty and struggle during practice is not a sign that you're failing. Not at all. That uncomfortable feeling of frustration and struggle actually leads to greater structural change in your brain. Literally, the harder your brain works, the more it physically upgrades itself. And finally, number 3, there are 0 shortcuts. Nothing is more effective than actual practice. You just have to do the work.
I really want to leave you with this incredible thought. Every single experience alters the physical makeup of your mind. In fact, just because you've been sitting here focusing on this explainer, actually processing these concepts with me, your brain is physically not the exact same as it was 10 minutes ago when we started. You've actively changed your brain's network just by paying attention to this. So, if your mind is quite literally being sculpted by everything you choose to do and everything you choose not to do, the only real question left is, what are you going to wire your brain to do tomorrow? Keep learning, and I'll catch you in the next one.